Hi everyone, and welcome to the first video for Year 12 Math Methods. We're going to be making a start on the circular functions topic, so we're going to get stuck into degrees and radians. So to begin with, you can see I've drawn my unit circle here. Now the unit circle is a special circle which has a radius of 1 unit and helps us to develop all kinds of rules and different things. But I guess we need to talk about the actual definition of a radian. So a radian is the radius of the circle measured around the outside, and it's the angle which is produced by that measurement. So if I take this radius of 1 unit just here, and I were to stretch that around the outside of the circle, then it would probably go around to about here. Okay, that distance. Now, the angle which is produced there is approximately 1 radian. We use the symbol little c to denote the radian. So once we've done that, there's a few rules that we need to actually develop that are based on this. So the first one, it's going to be really handy to know how many radians there are in a circle. So we actually know that in the circumference of a circle there are 2 pi radii, and this actually tells us exactly what we need to know already. There are going to be 2 pi of the radius going around the outside of the circle. So if I start off measuring my angle here at 0, we always start measuring at the positive direction of the x-axis, then by the time I get through a full revolution of the circle, I'm going to be passing through 2 pi radians. And we can use this now to figure out that, well, if a full circle is 2 pi, then over the other side, the half circle is going to just be pi radians. And if I were to only go through a quarter of a circle, then I would pass through half of pi, which I can say is pi on 2 radians. Or likewise, if I were to go through 3/4 of the circle, that's 1.5 pi. And the way that we write 1.5 as an improper fraction is 3 on 2. So 3 pi on 2 radians goes down there. Now, additionally to this, we're going to develop the rules now. So we know that in half a circle we have pi radians, and so what we can conclude is that 180 degrees, that's half of the circle, is equal to pi radians. This enables us to develop 2 rules for converting between degrees and radians. So the first one, we could divide both sides of the equation by 180. If we were to do that, 180 divided by 180 just gives us 1 degree. And on the right hand side of the equation, pi divided by 180 is just going to stay as exactly that because it doesn't simplify very nicely. Alternatively, I could choose to divide both sides of the equation by pi. So on the left hand side, we'd have 180 over pi. And again, that's not going to simplify, but on the right hand side, pi divided by pi is just 1, and that was measured in radians. So these are the 2 equations that we have for converting between the units. And so what I'm going to do next, let's have a quick look at an example. So convert 30 degrees to radians. So if I have to do this, well, I know that 1 degree is pi over 180, so I could just do 30, because I've got 30 degrees, so 30 lots of that, 30 times pi over 180. And you can simplify it now or simplify it later, it doesn't make much difference, but 30 times pi is just 30 pi over 180. And we can simplify that down. 30 goes into both of these numbers, so 30 goes into itself once and it goes into 186 times. So we're left with 1 pi over 6. And you might remember that from your exact values from last year. So what if we were to go the other way? Convert 5 pi to degrees. Now if we were to do that, then we would do 5 pi times 180 over pi. You'll notice that the pi's cancel each other out, and so we're left with 5 lots of 180 degrees, which is 900 degrees. Anyway, thanks for listening guys, see you next time.